Hey guys, welcome to the next lecture. So today we are starting the topic of derivatives. And to get the concept right, to get this concept in a very wholesome manner, I'm going to teach it. I'm going to give you three ideas behind it. So I'm going to make use of three different ideas to the same thing, the concept of derivatives. So what are these three ideas that I'm talking about? The first idea is the idea of velocity. So it's easy to actually understand derivatives in terms of velocity. Then we all know that derivative is associated to tangent, right? So the second idea that we will work on is the idea of tangent. And the third idea is the idea of rate of change. I'm not saying that these three things are different. They actually are associated to the same concept. But we will make use of these three ideas while working at this same concept of derivative, rate of change. What is velocity? Hota kya hai velocity? Velocity and speed. I'm sure both the things, speed kya hota hai and velocity is associated to speed only, right? Speed is essentially how fast I'm going, or how fast is a car going. How fast? Velocity is when you have speed in a particular direction. So speed and direction together makes velocity. Conceptually, this is what velocity is. So of course, it's associated to speed, but along with it, when you attach direction, it becomes velocity. Now, you must have quite often heard the word instantaneous change, instantaneous rate of change associated to derivative, the concept of derivative. So yes, the concept of derivative is associated to instantaneous rate of change. But it's quite a funny scenario. Why? Because think about it. Change कब होता है? Change होता है जब एक जगह से दूसरी जगह जाया जा रहा है, तो ये change हुआ, right? This is change. So when you say instantaneous मतलब at that instant. So at this instant, अब मैं आपसे पूछूं इस instant पे क्या change हुआ? आप क्या बोलोगे? क्या change हुआ? So instantaneous rate of change. That is why, in order to even understand the instantaneous rate of change. Now, instantaneous rate of change as such means कि एक instant पे क्या change हो रहा है? Rate of change क्या है? But rate of change you can only figure out when you have 2 points and some change is happening. तभी तो आप बताओगे कि okay, rate of change क्या है? But now how in the mathematicians, Weierstrass and all, they conceptualized it like that कि हम instantaneous change भी बता पाए. Instantaneous change क्या होता है? At the instant, what is the rate of change? Well, that's, my dear, is the concept of derivative, and इसी को हम इसलिए तीन तरीके से देखेंगे. तो velocity, first let's think in terms of velocity. So thinking in terms of velocity, car का example लेते हैं. Let's take an example of a car. So you have a car, और कार ने मूव करना है. मान लेते हैं कि कार मूव कर रही है एक पॉइंट से दूसरे पॉइंट तक. So a car moves in one particular direction, right? A car moves in one particular direction, for example, from one position to another position. It starts slowly. So it's slow here, speeds up here, and then again it is slow. Then again it is slow. Okay. Now, if you visualize this in terms of relatively in relation to time, so perhaps what we can do is we can just take this idea of speed as a vertical, you can just take it vertically, and graph is vis-a-vis time. So let's do that. So if we have time here, and we have the way the car is moving here. So the car, perhaps it just starts like this, speeds up, and then, it's again sort of slowing down. This is how the car is moving, right? So we have just seen how the car moves vis-a-vis time here. So suppose this S is basically, the horizontal line that we had here, which is telling about car's position at different moments. What is the car's position? So suppose this is car's position and this is car's time, or the time when the car is moving. So car is moving something like this. Now here you would notice that position is only increasing in terms of it's just going towards right? It can be with high speed or low speed, but it's just moving positively. So that is why you would see that it's just going up, 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 up. Sometimes it's moving up very slowly, but sometimes in a fast manner. Okay, that's what is happening. What you can realize out here is that there is a change in position at every moment. At every moment, there is some change in position. Similarly, there could be a scenario where we think of a particle dropping down a particle. Then it would not be like an increasing thing. It would be a decreasing thing. So yes, there could be change in position in a decreasing manner also. You could think of, probably throwing a ball, any particle, anything falling down, right? There could be some speed attached to it. So suppose, I'm standing here and I throw a ball. A ball moves up, but ultimately, because of gravity, it will fall down, right? So it will fall down. So in that scenario, what will happen? The position is falling down. Okay, so it might not just always be a positive direction. It could be falling down thing also. Or maybe thinking in terms of relation, what you can see here is that S increases as T increases. And here, S increases, but then it decreases. First, S increases, then decreases as T increases continuously, right? So we can actually view this S, which stands for position of the object, okay? S as a function of T, time elapsed, okay? Whatever time has been used, S position is either increasing or decreasing, or first increases, decreases, anything can happen, okay, in that sense. So we can take S as F of T, function of T, where T is the time. So F could be said to be a position function. F could be said to be a position function, okay? For example, position function of a particle could be 1 plus 5t minus 2t square. So it's purely a function of t, where t stands for the time being used, okay? Now, in that kind of a scenario, we can actually introduce the concept of average velocity. So what would be the average velocity? What is the, in other words, speed with the direction? Direction, we can assume that it's just going in one direction, like the car or ball. So what is average velocity? Average velocity, I'm sure you're thinking what I'm thinking. Average velocity will be the change that occurs in position upon the change in time, that is the time used for that change. So average velocity will be change in position upon time taken for that change to occur, that is time elapsed. So that would be, say the change is in time is h. So that is your t variable. The change in that is h. So that means you are in a new position at time t naught plus h minus the initial one, say initial time is t naught. That is the average velocity I'm talking about in interval t naught to t naught plus h. Okay. So if you take this, where h is strictly greater than 0, where h is strictly, because we are talking about change, some change is happening. For example, if you have this function, then what I can ask you, what is the average velocity? So average velocity here would be, average velocity here also would be t naught plus h minus f of t naught whole thing upon h. Now we need to know which interval we're talking about, that is which time interval we want. So suppose we are looking at 0 to 2 minutes. So in 0 to 2 minutes, this particle, 0 to 2 seconds, 0 to 2 minutes, any unit could be used. So in 0 to 2 seconds, say, where the particle reaches. So this basically means that 0 is your t naught and 2 is your t naught plus h, which means h is equal to 2 because t naught is 0. T naught is 0 and h is 2. So the change in time is 2 seconds, which means we are talking about here f at the second minus f at the 0 second whole thing upon 2 seconds. So that's going to be, just put the value there, you will get 1 plus 10 minus 2 into 4, that is 8, and minus f0 is 1. Whole thing upon 2. So that's going to be 2 upon 2, that is 1. So this 1, what you have got, what is it? It is the average velocity. It is telling you that this particle is moving with the velocity 1 meter per second. It's moving with the velocity 1 meter per second, or whatever is the unit that could be dealt with. I did not specify it because you should know units is something that would be given in a question or in any scenario where you're using this concept. You would know what units you're talking about, right? What is the particle? Is it a car? Or then what's the speed like? What are the units that are being used? So that depends on question to question where you're using this concept. Suppose with the same function, you are asked to find the instantaneous rate of change. Find the instantaneous rate of change. Or velocity, in other words, has to be at a particular instant. So say at t equals to 2 seconds, okay? T, your time is 2 seconds. At 2 seconds, what is the instantaneous rate of change or velocity for the same function, okay? Then what will be your answer? What we just figured out was the average velocity that in between 0 to 2, 0 second to 2 second, this is how the particle is moving. So I could give an average estimate. But what about instantaneous rate of change? In order to understand this better, I would also want you guys to find out what is the rate of change of velocity, what is the average velocity of the same function in the interval, say 2 to 3. 0 to 2 we have, 2 to 3 let's figure out. 0 to 2 we already have figured out, right? So here this means that this is your T naught and this is your T naught plus H. Okay, so this means that H is equal to 1. So clearly f of T naught plus H minus f of T naught whole thing upon H is equal to f of 3 minus f of 2 whole thing upon 1. So f of 3, f of 2, just figure it out. The function is the same. It's 1 plus 5, 1 plus 5t minus 2t square. So if you try to figure out what is f of 3 turns out to be minus 2 and f of 2 turns out to be minus 3. And here you have 1, so that means minus 5 meters per second is the velocity of this particle in between the interval 2 to 3. Now, what am I asking you? What is my third question? What is my question here? The question that I gave you is that you have to find the instantaneous velocity at 2 seconds. I know that in between 0 to 2, it is 1 meter per second. I know between 2 to 3, it is minus 5 meter per second. What is it at 2? That's what we want to figure out. So this is a crucial question. Let's think about it in terms of values. So in case I think about values, I already have few values here. If I take t, let's take t, intervals for t, and let's take average velocity and analyze this situation to find out what is happening at 2. So what I'm going to do is I'm going to try to go closer and closer to 2. So we have t is between 2 and 3. What is the average velocity? We've just figured out it's minus 5. If you will take t between 2 and say 2.1. Okay, so that's like close by 2 only. So if you will take 2 to 2.1, so this will give you the situation where you have f of 2.1 minus f of 2 whole thing upon the change in t is of 0.1, so the denominator will be just 0.1. If you will put in the values, pause the video and try it out. When you will put in the values, just put it in the formula. So here I've done my rough work. So here you will get minus 3.2. Similarly, let's get even closer. So you will have 2 to, let's say, let's take the interval. By the way, we're equating it also because we're using the endpoints. 2.01. It's going to give you minus 3.02. When you are between 2 and 2.001, the result that you will get is minus 3.002. When you are between 2 and 2.0001, what you are getting is minus 3.0002. Can you see what's happening here? The closer and closer I am moving towards 2, the closer and closer I'm moving towards 2, the smaller and smaller changes if I'm taking. When h is getting smaller and smaller and smaller, that is, I can say in some, in other words, that h is almost tending towards 0. I'm not saying that it is 0, because when h is 0, this ratio is not defined. So it is not 0. It is something very, very, very small. So we're almost reaching 2 only. But well, h is still some value. It is some value, but it is almost tending towards 0. And when that is happening, as far as average velocity is concerned, of this function, average velocity is moving towards -3, it seems, because it's turning closer and closer to -3. Isn't that so? So in some sense, you can get an idea that, okay, the average velocity, not the average velocity anymore, in fact, because as we are taking smaller and smaller h, I could even, make it even, point 2.000001, and you would realize you're getting -3.000002, you'll be getting something of that sort. So which means that this is not average anymore, because we're so close to 2 that this is almost the velocity at 2. So it will almost become velocity at 2, because it is velocity at an instant. It's called instantaneous. So it's velocity, almost velocity at an instant. Otherwise, at the instant, speed does not make any sense, because at the instant, it's like you're not moving. How do you say that you're moving? But we are talking about rate of change. It's not that it is not moving at all. It has been moving. It moved till certain point, and then it moved again, and that is how this interval got created, right? But then we are saying that, okay, if this movement is restricted to very close to this point itself, then we can talk about what is the kind of rate of change occurring at that point. That's the whole idea of instantaneous rate of change, and which is reflected or depicted in different manner. Now here I tabled down values for you. Now let's learn how to actually calculate it as well. So the whole idea was, as h is almost tending towards 0, right? What are we interested in? Our velocity would become a velocity as such. The average one was f of, in case your initial point is 2 plus h minus f of 2, whole thing upon h, that's the time elapsed, okay, which will be equal to 1 plus 5 times 2 plus h minus 2 times 2 plus h square minus 1 minus 5 times 2 minus 2 times minus plus 2 times 2 square, whole thing upon h. So that's going to give me I can just open this up, cancel out things. So f of 2 is actually 3, so we can just say that it is 1 plus 5 times 2 plus h minus 2 times 2 plus h whole square minus 3, which will give us minus 2 plus 10 plus 5h minus 8 plus 8h plus 2h square, whole thing upon h. This is what you will get, right? But what are we interested in? We are interested in instantaneous rate, right? So instantaneous velocity. Which, if you've understood, is nothing but limit as this h goes to 0 of this expression, that is your change that occurred in the position upon time elapsed, 10 plus 5h minus 8 plus 8h plus 2h square, whole thing upon h. So if you open up your numerator now, you will get minus 3h minus 2h square. Holding upon h as limit h goes to 0. So we'll be using the concept of limit because, as I said, h is not exactly equal to 0. It is tending towards 0. So here h cancels, and what you get here is minus 3 minus 2h as h goes to 0. Since h goes to 0, this will just give you minus 3, which is intuitively what we figured out using this table and going closer and closer to 2. That's what our intuition said. We are moving towards minus 3. And yes, the calculation also, using calculus, we could easily figure out that when we take that this time elapsed to be very, very small, extremely small, which basically means that we are just at that point, at that instant, we are actually at almost at that point only. That can give us the instantaneous velocity. So instantaneous velocity, again, instantaneous, a funny concept because instantaneous it talks about change at a particular time, and how can there be change at a time? But the concept is about, it's not that the objects have not moved till then. So the objects have been moving. So it's a relative concept. So what has been the movement relative to time elapsed, and when that you take that time elapsed to be so small that you're almost at that point, it is called the instantaneous rate of change. Now I'm going to continue this in the next part of the video, and we will relate it to tangent and rate of change in any function.